Okay, so what we're trying to do here for this first part is a one-tailed test where Z, the test statistic, is 1.70 and alpha is 0.10. So what we need to do is think about our normal distribution, and if we look up on our table 1.70 where alpha is 0.10, well, first of all, 1.70 would be 0.9554. So 0.9554 would be right here. First, let's write our test statistic down, 1.70. So 1.70, let's just say 0 is right here, okay? Well, 1.70 is positive, so it would be somewhere over here. Now, when we look it up in the table, it's going to give you the probability up to that value. That's what that's going to give you. So if we look it up in our table, when you look it up, you get 1.70 right here, 0.9554. So 0.9554 is the area that's highlighted. The probability of it being highlighted would be that area. Well, we want to know the p-value is the probability of it being as extreme as that. So we're looking at this tail over here to the right of 1.70. Well, if the whole area under this curve is 1, and we know the highlighted area is 0.9554, well, to figure out the area to the right of that, you would say take 1 and subtract out the other area, and that is going to give you your p-value. So the p-value is 0.0446. Okay, so that is how you get the p-value there. Now, we are going to figure out, do we do not reject or reject the null? You're either going to reject it or not reject it. You're never going to accept the null. Those are your two options. Well, your p-value was given, your alpha value is given, so let's go ahead and put p down. P is 0.0446, and your alpha was, okay, so you see it right there, 0.10. So 0.10, well, 0.0 is smaller than 0.1. Okay, so since your p-value is smaller than your alpha value, you are going to reject the null. Okay, now let's look at the part B. Okay, so for part B, one-tailed test where your your test statistic is -2.15 and alpha is 0.05. So I'm going to write that information down. Okay, so -2.15, let's go ahead and draw. -2.15 would be right here. Okay, and 0 would be your midpoint here. So negative 2.15 would be really this tail right here. So we can look that up on in our chart. Negative 2.15 would be 0.0158 would be our p-value. 0.0158. So this tail right here is 0.0158. Okay, so we know that our alpha is 0.05. So let's compare P with our alpha. So I always put P and then I put alpha. I always write P first when I'm comparing. So P is 0.0158 and alpha is 0.05. So 0.01 and 0.05, P is less than alpha. So since P is less than alpha, we would reject the null. And HO is the null. So you can see where we've put in the p-value. Make sure you round to 4 decimal places, which in the table it's already rounded. And then you have to choose reject for those two. Now let's look at a two-tail test. So for a two-tail test, we're going to be given the test statistic is 2.50 and alpha is 0.10. Okay, so since this is a two-tail test, we're going to have tails on both sides. Now we just need to look up 2.50 on our table. And 2.50 is 0.9938. So let's talk about, since it's a positive value, let me get over there. Since it's a positive value, we're going to, it is going to include the left tail, and it's going to stop somewhere, and we can guess where. But what we need to know is, if we want to figure out how much one of the tails is, we're going to do 1 minus 0.9938, and that will give us one of our tails. And when you do 1 minus 0.9938, you're going to get 0.00 or 0062. Now, that tells us the amount for one tail. Well, we have 2 this time. So you have to multiply it by 2, and you will get 0.0124. Okay, so now we can compare our p-value of 0.0124 to our alpha value of 0.10. Well, clearly our p-value is less than our alpha value. And what do we do if that's the case? Then we will reject. For part D, you have a two-tail test where your test statistic is -1.64 and alpha is 0.02. And so we're going to look it up on the table to see negative 1.64, 0, 1, 2, 3. So 0.0505. Now, when we're doing this, if you get a negative value for z here, okay, so when we're using the p-value compared to alpha, if you get a negative value for given a negative value for your test statistic, you don't have to say 1 minus. Whatever's on the table is your p-value. But if you're given a positive value for your test statistic, you have to do 1 minus what's on the table. So that's a quick way to help you remember when to subtract and when not. So back to what we were doing. Negative 1.64 on the table. If you look that up, your p-value we said was 0.0505, but this is a two-tailed test, so we have 0.05 over here and we would have 0.05 over here. So anytime it's a two-tailed test, you have to multiply by 2. So your p-value is going to be 0.101. So we know that p is 0.101, and we know that alpha is 0.02. So clearly 0.1 is larger than 0.0. Okay, and if you have trouble comparing decimals, line them up. Okay, and you can fill in the 0 there, and you can see that 101 is bigger than 20. Okay, and since our p-value is greater than our alpha value, we are going to choose do not reject the null. Okay, so that is how you will work question 1 as well as question 2. So let me know if you have any questions about these first 2 problems on your homework in section 9.2.